Yes, sir. Yes, sir.
Your
You
question?
answered it, sir.
Okay, okay.
Yes, sir. You answered it, sir.
Okay, okay.
Thank you, sir.
Am I audible,
Okay.
sir? Sir, am I audible,
Yes,
sir?
sir. Yes, sir. Yes, sir. Next session
Okay,
will
okay.
take place by Dr. Ganesh Kumar, sir. Is going to be intro with your TinkerCAD and how it is going to be applied in robotics, right?
Thank you, sir. Thank you for giving a brief
Thank
introduction about me. Right.
Hello, sir.
Okay.
Hello, sir.
Professor Dharani Kumar. So now
Yes, sir,
we are
yes, sir.
going to share the screen. Right. I'm going to share my screen. Is my screen visible to you?
Yes, sir.
Is my screen
Sir.
to you? Okay. Okay.
Yes,
Thank
sir.
you. Thank you. And I logged the meeting. Right. Logged the meeting. And in the previous class, we discussed about the 3D designs, detailed view. We discussed about the 3D design, how to create a 3D model. It's a basic. I am agreeing with that. This is not competing with the commercial software. I told you already. This is not going to compete with the commercial software like CATIA or SolidWorks or 3D elements. But this is a basic version somewhat, right? You can print the 3D objects and you can fabricate a robot, right? Because this 3D model is a soul of a robot, right? See, it is a part, right? See, it is a static and it is a part. It is going to build the robot. So we discussed about this 3D model. And today we are going to see about circuits. Students, is my screen visible? Screen and my cursor visible?
Yes, sir.
Yes,
Okay, thank you. Thank you for your feedback. Thank you. And in this second module, you're having circuits, right? So in the circuit, I worked already so with some circuits, see like this. See, it is a basic simulation. But before that, I will tell you what is meant by Arduino, right? This is Arduino. We can simulate Arduino. Before that, I will tell you what is meant by Arduino. It is a basic board. You did so many projects now, so I hope you did so many projects in Arduino. I will tell you what is Arduino. Arduino of it's a basic development board, right? It's a basic development board of price nearly 500 rupees. Arduino UNO. We have several versions of Arduino. It is Arduino UNO, Arduino Nano, Arduino Mega. Every see this. Every version is having its individuality, right? We have some remarkable properties for every versions of Arduino, right? This Arduino UNO is a basic version. It is a basic development board. Okay, we are calling it as IDE. It is Integrated Development Environment. We are calling it as IDE because it is a basic development board. We are going to develop some new things means then we are going to use Arduino. But I am agreeing it is not a professional one, right? This Arduino is not a professional one. If you are going to give a program for a washing machine or a mixie, then if you are going to do in a professional way, then you are not supposed to do this Arduino. Okay, then you have to use a separate microcontroller. It is specially designed microcontroller, right? See, the same work is done by Samsung and LG also. They're having their individual controller, right? So this Arduino is a microcontroller. Before doing the simulations in TinkerCAD, I will explain the basics of Arduino, then we will enter into simulation, right? See, because it's a simulation environment, that's all. You can simulate it. But I will tell you about this Arduino basic things, right? We have types of Arduino, then see, I told you already, there is Arduino Nano, then Arduino Mega, so other things, right? Now, you can give the program, okay? See, since it is a IDE environment, you can develop your own creativity, right? So see, simply, see, it is based on your creativity. You can give the program, so you can change the program, right, to this Arduino. So you can change the program. Say, for example, if you're having a washing machine, they have a controller from LG or Samsung, then you can change the program, right? It is read only memory. So it is wrong. But you can change the program in Arduino. It's a specialty. So only it is suitable for students. Okay. If you are going to do professional means, then how it will be? We will see, right? This same program, the same concept is applicable for the professional one, right? We will do later, but this is a basic environment. Okay. Now, so now I'm going to tell about this Arduino and the pictures, right? Okay. This is a type of microcontroller. Now I will explain the term microcontroller. See, what is mean by microcontroller means it is like a computer. It is like a mini computer, right? This is an Arduino board. This Arduino board is having a power supply unit, it having a storing area, then having the input peripherals and its output peripherals and output pins, so other things, right? We have all these parameters inside a single board. This Arduino is having all these pins, all these facilities in a single board. You're having all these facilities, right? Okay, so say for example, I'm having this picture, right? This is Atmega. This is Atmega means it's a brand of this chip. See this IC, right? See this, and it is developed by Atmel. Okay, now this IC is fabricated on this bed, and you have a IC and this pins, right? We have pins like this, and we have this power supply unit and other things, right? You can program it, right? Then you can erase the program. Then you can give the pin connections. Then you can give this pins. See, it is called as input pins, right? Then you have this. It's called as output pins. You can do this using this Arduino. So this is a brief introduction. Then, so now I will tell you how this Arduino is used, right, to do the projects. You can build a robot. See, first your question is, right, sir, why you are teaching this Arduino to build the robots, right? It is a type of microcontroller, it's a basic microcontroller. Even you can go for a Raspberry Pi, right? It is also a type of microcontroller. You can do a robot using this microcontroller Arduino, or it may be Raspberry Pi or whatever may be, right? Now, this Arduino having several versions, I know, right? Now we have this Arduino Lily. This is a version of Arduino. This is Arduino Lily Pad. It's called as Arduino Lily Pad. It is also a microcontroller. This is also like a computer. It is also like a computer. It's having this read-only memory, have a chip, and have its input pins and other pins, right? Depends upon the situation, you are going to use this Arduino Lily, right? And this Arduino Nano and other things. Simply, see, students, please make a note and search these things in internet. You can learn several things. We are giving only the hint to you, right? In this 6 days, we are giving only the hint. You can learn so many things in internet, right? So this Arduino Lily, and we're having this Texas. See, it is called Texas Launchpad. So I will tell you Texas Launchpad. It is also a type of control. It is a type of microcontroller, but it is costly. But this Arduino costs nearly 500 to 600 rupees, but this Texas is costly. Then only, so only we are using this Arduino for the IDE environment for the students, right? So the concept is same for this Texas instrument. Yes. Somebody is asking any permission. Okay, I will continue. See, the concept behind this Texas instrument, then Arduino Lily, Arduino Mega, Raspberry Pi, all is common. If you are going for a Raspberry Pi, then you will do the program using Python, right? It is a programming language. But this Arduino, okay, but in Arduino, you can program using a C platform. Okay, C platform. You can use this C platform and this C text, C syntax. C syntaxes you can program. We will see one by one. It is a programming part. Okay, I will tell you the programming part later. But in this microcontroller, we have two portions, right? We have two portions. One is programming part. Second is hardware part, software and hardware. That's all. Right? It's like a computer. I told you already. It's like a computer. Okay. It is having two portions. One is software and another one is hardware. Okay. Hope you can understand, guys. Now we have a software. Software means nothing but a program. You know, right? It is a script or a sketch. Okay. In this Arduino, here we will call it as a sketch. Sir, the Texas Launchpad, somebody is texting. I will give the answers to all your queries, right? So at my end of the session, please be patient. You can give your chat, then I will reply for all your queries at the end of the session. So please give your text, okay? Now, we have two portions. First is software, then second is hardware. In the software, it is nothing but a program. We will call it as a program, but in Arduino, we are calling it as sketch. Sketch means program, that's all. Or it is often called as code, C-O-D, code, right? So we know have two portions, software and hardware. I told you already. Now we are going to see one by one, software and hardware both. But the hardware, it is sensors and other circuits and its pin configurations, etc. Right? Now we are having Arduino. There's an Arduino, right? You can see this Arduino. It is made in Italy, right? Okay, and it's a symbol of Arduino. You can use the software, right? We have a separate software and it's a website. This is www.arduino.cc, right? You have a website. Don't bother about TinkerCAD. It is just a simulation, right? We use cookies only require accept all. Okay, some cookies is disturbing me. Oh, I'm sorry. Buy Arduino, learn Arduino, then Arduino in cloud. Okay. This cloud means it is through internet. That's all. We have a huge repository. It is like a e-library. That's all. You can download the software. This is a software. You can download the software. Then you can send the program to the Arduino, right? This is a hardware part. This is a hardware part. Then, if you are giving the software part, once if the time permits, see, since this condition is pandemic, don't go outside. Be safe, home, right? If the time permits, right, buy one Arduino and learn Arduino, right? Download this latest update, right? 64-bit or 32-bit, then it will work, right? For Windows, then it will give the facility to feed the program. I will give you a video, guys, because all the techniques cannot be taught in the 6 days. Right? See this 6 days is very, very less time to handle this Arduino, because this is a very huge topic, right? So this software permits or gives the facility to give the program to the Arduino. It can erase the already pre-written program. You can give the program, you can edit the program, or you can change the pins also through the program, right? It gives all the facility. You can download this, right, to this latest update. This is arduino.cc. Okay, this is the story behind Arduino. Yeah, gentlemen, now we are going to see the simulation, because since this is simulation software, right? This TinkerCAD is a simulation, that's all. But you should know the story behind Arduino and what is Arduino. You should know that, right? Then only this simulation will be a useful one, right? If you're going to simulate through this Arduino and an LED, means it's like a video game, right? You have to know the story behind this Arduino, then only it will be useful, then it will be a meaningful one. Right, now I'm going to give a simulation. Before that, I will give you a small exploration about this hardware, because this hardware is important. If you are going for Raspberry Pi, the same hardware can be used. The sensors like this temperature sensor, this potentiometer, slide switches, this same hardware can be used, right? The same hardware can be used, and this is the latest update in TinkerCAD. Okay, so in the previous version of TinkerCAD, they didn't updated this. Okay, then it's a DC motor, then this is a vibration motor, servo motor. This all are the hardware. As our professor Dharani Kumar told the detailed theory of a sensor. See, because this theory part is very important, right? Because the theory part helps you to know the concept behind what is known as microbit. I will tell you, gentlemen. Right? Please see. Wait, I tell you. Somebody is talking. Please mute yourself. Okay. Now we know this hardware. See, because this hardware is these hardwares are well known to you, right? This resistor, LED, and this push button, potentiometer, everything is well known. So now I'm going to skip this because this is basic, right? School students also, they know, right? So now I'm going to pick this Arduino and I will tell you the pin configuration because we are going to focus the Arduino. If the time permits, and if you're having some other sessions or some other meeting, then we'll discuss about Raspberry Pi detailedly. It is a Python platform. Now we are going to see about this Arduino. You can name or rename, say for example, it is a microcontroller, and rename the hardware component, right? You can rotate this component. You can rotate this component. Is right. System is slow, right? Okay. Now we have a pins, right? We have a pins. This is a picture. It is not a real Arduino. It is not a real Arduino. So you can simulate. Simulate means what? It is like a virtual environment. Simply, it's like a virtual environment. You can simulate. That's all. Okay. So in this, they have a pins like this. Pins 1, 0, 1, 2, 3, 4, 7, right? Ground, other things, right? Then this is analog. This is analog input. This is analog input pins. Then this is TX and RX, right? It is to transmit the data and to read the data. See, you having the pins here, right? We have the input pins A0 to A5. So totally we having 6 pins. It is analog input pins. We have a 6 pins A0, A1, A2, A3, A4, A5, 6 input pins. Through these pins only, you have to give the inputs. Okay, how we can give input? As our Professor Dharani Kumar told, some sensors is giving signals to the control. Sensor means, so now let us take a sensor, right? Sensor, you can search also. Basics, all, this is all things, right? This is all thing. Arduino, Lilly, ultrasonic sensors, everything, right? This is an ultrasonic sensor. This ultrasonic sensor, we have a 3 pins. For all sensors generally, right? We have a 3 pins. We have ground and a 5 volt and signal. What does signal means? We have a certain range for all sensors is having some certain specifications. If you're going to search the specifications of an ultrasonic sensor, you can see the distance of its proximity, right? Say for example, its distance is going to cover or the distance is going to sense. Simple. This ultrasonic sensor is used to sense the object in front of the sensor, right? So you can sense the object using the Doppler effect. Did you study the Doppler effect in your physics? Hope you studied, right? Please don't unmute. Okay. Now you can sense, and the sensor is going to give the signal, right? This is a signal. As in the previous session, Dharani Kumar told, the tongue is going to give the signal to the brain. Now this sensor is going to give the signal. There is the output of the sensor. We are giving as an input to the controller, right? You can connect. You can connect using this wires. You can connect using this wires, right? Okay. Now you can give the ground also. You can give the ground here. You can give the ground. Then you can use the supply, other things, right? Then you can start simulation code, right? So this is the basics. And this is a power supply. This is a power supply. We have two different power supplies, right? Through USB and this power supply through an adapter. And now this specifications of this Arduino and this ultrasonic sensors is here. This is ultrasonic sensor. Ultrasonic sensors. This is ultrasonic sensors, cost of nearly 100 rupees. So it depends upon the range of proximity. Students, please mute. I removed one fellow previous just 10 minutes before I removed one fellow. Okay, please stay muted. Okay. Now we have some other sensors like PIR sensor. PIR sensor. This is a PIR sensor. Full form of PIR sensor is passive infrared sensor. It depends upon see the concept behind the PIR sensor is thermal imaging, right? You know the concept of thermal imaging because this sensor works based on the infrared rays, right, emitted from the body through the heat energy, right? The heat energy, if a body is having a heat energy, then it will emit some infrared rays. Based on the infrared rays, then it will sense us and give the signals. Okay, as usual, we have a 3 pins ground and power supply signal. We have a power supply, guys, because this power supply is because the sensor is going to need some power supply to work, right? So we are giving the power. See, we are giving the power supply. Then this ground, we can use this ground also, right? So this is the basics. Now I'm going to simulate and the stepper motor and servo motor and other things. You can use the breadboard also, breadboard and other things. It's my previous versions. It is the previous files I worked. I will share this file to you, right? Then you can use the code. Then you can edit the code also, right? Stepper motor, the 4 pairs and other things, right? Simple. We have a stepper motor. I will tell you the concept of stepper motor today. Stepper motor and servo motor. Listen carefully because the servo motor having the pin connections, right? We have a circuit connections. Based on this, see this is called IC. It is L293D. This is L293D is IC. You can also drag from this L293D, like L293D, right? So this you can give. There is a bridge motor driver. It's a driver. It's a simulation environment, no? Okay. Now you can search L293D, no? L293D, right? This is the IC. That's all. You can give or you can get the detailed pin configuration. So my dear students, please search in internet. Simply I'm giving the hint, that's all. You can search in internet, see about this individual ICs, this L293D IC. You can give the ground, then you can get the supply and the signal and other things. See? So this L293D is called as driver IC. Is a driver IC with this power supply module. We have this power supply module and other things. So it's a total IC, and this is called as IC bed. You know very well. The students who are studying electronics, very well. Right. This is a stepper motor. The stepper motor is having 1, 2, 3, 4, 5, 6 terminals. You have to search each and every terminologies, keywords I am telling. Okay. So this is a stepper motor. The stepper motor is having separate coils. We have a separate coils. You can control by steps. Steps means what? So you can control at a particular angle. If you are going to control see a motor to the 60 degree to 65 degree means then you can control using the stepper motor. So it's a purpose of stepper motor. If you are going to use a servo motor, then you can use servo motor also. Okay, then you can give the code here. Here I use the code already. This is a C environment, right? This is a syntax from C. This all the syntax is from C. This void loop and other things. If you know C, then it is very good. If you are using Raspberry Pi, then this environment is Python, right? You can use artificial intelligence and machine learning in this Arduino Raspberry Pi. Okay, you can use the tool machine learning and artificial intelligence to this Arduino Raspberry Pi. This much of efficiency it's having, right? We are students, and see, our circles is not using this Arduino as efficiency well, right? Because it has a huge efficiency. So we are not using that much of limit. Okay, it's my point. Now you can use this, and this is not required, or you can delete this, or to give the explanation we are giving the slash and nothing to inside the setup, and we are giving the pin connections and other things, right? We are giving the pins 8, 9, 10, 11 now. This is 8, this is 9, 10, 11, right? We are giving the pin connections and pin number. As I told already, we are giving the outputs. This is the output. We are giving the signal, simple. Then here no sensor is available. No sensor is available, or no sensor is connected. So leave it this input connections. We are giving the power and ground. We need power and ground. So it is taken commonly to the breadboard. You can take the breadboard also. You can take the breadboard. You can take the breadboard, no? Breadboard. I have two varieties of breadboard. Everything have a 2 to 3 variants like a car. Okay. You can search the breadboard also. System is slow. Please wait. It's running. Breadboard. Basics. You see, it will be available. All. You can search the breadboard also. Right. This is Arduino, Lily, and other things. So we will. So now we will discuss. Right. It is a breadboard. We have 3 variants. Breadboard mini. So it depends upon the complexity. You can select. If you're having the complex circuit, then you can select this huge breadboard, or if the circuit is small, then you can use a small breadboard and other things, right? You are going to use this driver, then you can search this L293D, L293D circuit connection. You can search this. This is available. It is a standard, because we can't change the circuit and the pin connections or pin configurations of L293D, because it is fixed from the developer of 293D, right? It is fixed. So you can use, or you can apply this pin connections to our project. That's all, right? You can use this to our project. So this pin connections is common. So based on the pin connections, you can use this L293D to this pins 8, 9, 10, 11. We have a 4 pins, no, 4. We have a 4, and we're going to take supply. We have a 1, 2, 3, 4. See, you're having a 4 terminals. In this 4 terminals, you can give the 4 inputs from the board or from the driver. Then you're going to give the supply from the battery, right? Then you can simulate. You can simulate this. You can simulate. Yeah, it is running. You can see it is running, right? So now I will tell you the difference between servo motor and stepper motor in my forthcoming classes. And this 6 days is not enough to complete this Arduino, because it is a huge. It's a C, right? Having the toys also. See this toys. It's like a kid's toys for school children's, right? Servo motor and other things. You have a potato battery and lemon battery and other things. See, it's a new updated TinkerCAD. Okay, so I saw now only potato. Yeah, they have updated these 2 things, right? It's not there in the 6 months before, right? And this is LCD. We have a 7-segment display, IR remote, piezo sensors. It's nothing but a speaker. That's right. This is a piezo. It's a And my dear students, so now the time is running. So now the time is 11. So we will conclude the session. Please search in internet and see, stop the simulation because system is running. Okay, now I'm going to reply for your chats, right? If you have any doubts, feedback is apart. You can give feedback later. So now didn't get the link yesterday. We will share the link, Kana Vignesh. We will send the link. Yes, ma'am. It's opening. Okay. What is known of microbit? I will send you a video for microbit detailed video. Okay, students, is my voice audible to you? Is my voice audible?
Yes, sir.
Thank you, thank you. And you can chat in the chat area whether we are able to simulate any camera modules in TinkerCAD. Well, see, simple. We have a limitations. Listen carefully. I will tell you for his doubt. Right? Oh, cancel. Session is going to end up. Okay. If you're having any camera modules, see, because this TinkerCAD platform is run or is controlled by the TinkerCAD team, right? It is maintained by Autodesk team, right? If they are including, if they are updating any camera modules, then you can simulate. Now, as of now, there is no camera module, so you can't simulate. So it's better you can simulate with some other sensors, right? Then you can replace with the camera. So it is my better idea. Okay, so I think so your doubt is cleared, Hariharan. I hope I cleared your doubt, Hariharan. Tell about passive sensor, please. Right, passive sensor. There is a passive infrared sensor. We have two type of sensor, active and passive. Right? Say for example, if you are need some power, if you're not requiring any power, then we will classify this passive and active sensors, right? This is divided into two types, this passive and active. Okay, so we are going to classify based on this category. I hope you get the clear idea about the passive sensor. This is a common, see, this passive is a common category, but this passive infrared sensor is coming under this category. If there is any other simulation platform for simulating camera modules, as of now I'm searching. Okay, Hariharan. So now, as of now, I'm also searching that. If you're having, if I know any simulation module for camera, then surely I will tell you for your project. Okay, hope you're very much interested in simulation, right? See, because it is very easy. Okay, we are not spending any money. Simple. It's like a video game. It's okay. It's like a hobby or it's like a passion. You can simulate. Okay, very good. We can log in mobile phone, sir. Sure, sir. No issues. Okay, go to the desktop site, then you can log in, sir. Prithu Rajan, I hope I gave a, so I gave the doubt clear, no?
Yes. Yes, sir.
Okay,
Yes, sir.
okay. V. Kishore Kumar is telling, sir, the Texas Launchpad where they use. Yeah, it is a professional software. If you're using the professional environment, Texas Launchpad is used. The cost is say nearly 70 to 80,000 rupees. But you can control. See, if you are using this Texas Launchpad microcontroller, then you can achieve very high precision and accuracy. Okay, for precision and accuracy, they are costing, right? Texas Launchpad. Okay, so
Okay, sir.
use Texas Launchpad, but this cost is very high. This cost, see, actually they are costing that much to achieve the high precision and accuracy, Kishore Kumar. So I hope I cleared your doubt, Kishore. How to log in TinkerCAD? Nitin Gowda.
Okay, sir. Thank you, sir.
Okay. Simple, Nitin Gowda. Don't worry. Go to the TinkerCAD website and log in using your Gmail account. Then you can enjoy the TinkerCAD. Okay, it's like a video game. Enjoy yourself, right? Okay, Nitin Gowda, I hope I clear your doubt. And so now it's a time to giving feedback. Okay, students, you can give the feedback about the session. Then we will shining off. Thank you. Please give your feedback. Okay. Nitin Gowda, a good experience, Tashwin, PSG Polytechnic. Thank you, Tashwin. And okay, please wait. I will switch off my recording. Okay. Okay. Recording in progress. Okay.